Hello and welcome to Bug Free Productions. Remember to subscribe on YouTube at Bug Free Productions and follow on Twitch at Jib@BFP. So, let's begin. Alright, so now we're going to cover our clock system. So, clock system consists of a single manager that exists in the scene using the singleton. We covered that just a few minutes ago in a different clip. So, feel free to watch that when that goes up on YouTube, and drop some questions in the comments if you have any. But for clocks, we're going to move on to clock manager and clock. So, what do we do with this? So this clock manager being a singleton, there's only ever one of them. We use that to make sure that we are updating our time correctly. And the whole idea behind the clock manager and the clock is to ensure that we do not ever have a bunch of different objects all updating the timings of our different objects, because we never want that to happen. We always want complete control and smoothness out of that. So let's look at it a little bit. How do we achieve that? So we're going to use a public or a protected list of our clocks. So this is where our clocks will be stored. And I think I was going to implement a subscriber pattern at one point, observer pattern at some point, but that kind of fell out of favor due to I just didn't really want to do, it seemed a bit like beating the dead horse, because there was no point for them to call to subscribe. It was entirely dependent on, like, it's pretty much going to be dependent on us assigning them, because they are scriptable objects. They can't exactly go into the scene and grab whoever's there. And also, they're not going to exist in every scene or be needed, so I'm just going to allow my clock manager to hold the reference for a prefab. So that's kind of my idea on that one. It's kind of developer's preference at that point. But we also have protected override void awake. So created in awake. Base is just kind of added. I'm not sure what all entails in base. For each clock in clocks. So every developer's favorite thing. 3 words that look almost identical in a row. Yes, check. And then we run each clock's setup. So every SCO, we run setup in our awake. And we do this because when the object is created, this runs. As long as the top level object is active, which it will be, because this is not a UI that that we have to have things turned off to turn on enable and stuff like that. So should be safe. At least until we network it, and then all safety is gone. Awesome. So then we have protected virtual void update. So just using the Unity method to update run clocks, and run clocks is actually based on completely self-contained. It is basically going to step through all of our clocks and tell them that time has passed, and it's going to tell them how much time has passed. Very simple script on the manager part. All of our actual difficult code is in the singleton, so feel free to go back and watch that once that goes up. Or watch the video here on Twitch. So we're going to go ahead and jump to the next thing. So what's after our clock manager? Well, if we follow the flow of time, like directly, we run to our run clock method. So jumping to run clock, here we go. We have running clocks, and we have setup. But before setup, we even have a scriptable object. So you'll notice the same boilerplate, create asset menu. I don't highlight too far to the right because it tends to jump around in Codium, so based on where your cursor ends. And then we have initialize on load. This is actually a holdover. I'm going to delete that. I didn't like it. So the thing I didn't like about it is that that's like a Unity editor thing, and that's only available in the editor. So if we set up our code to run like it's only in the editor, unless we're running something that is supposed to be in the editor, it's entirely defeating the purpose of programming it in the first place, at least in my opinion, because I don't have time to go back and recode things. Um, so I just kind of code everything to run as if it's going to be compiled. Uh, which maybe you have a test case or a use case that is useful, but for my general use, it is not. But we see scriptable objects, and we see iSubscription. So go back and check out the observer pattern video, or either the VOD or the clip, and check that out. But then we have a clock. So what does this mean for the clock? It means I want things to be able to subscribe to the clock. It's going to work slightly different than it has on other classes I've used the subscription interface on. So iSubscription is going to allow the item essentially to hold a reference that it can subscribe to. So they'll hold a clock SCO item actually, and then call methods implemented from iSubscription to implement the observer pattern. So let's go ahead and look at our vars region. So our variable region is protected float time interval. So this is the idea of how far apart we run our intervals. The time elapsed, so how much time has currently passed since the last interval change. And then protected list iSubscribe. So iSubscribers equals new list. So we're just holding a reference of how many subscribers we have and who they are. And the reason this is a list instead of on a delegate like we had in the last one is because it is going to be more convenient for looping and also indexing. Because if we had it on a delegate, we would just run all of them. But part of the thing with the time skip, or time step, not an anime, not a time skip. Part of the problem with the time step is that we're not going to be able to run through all of them in a single frame all the time. So we want the opportunity to control how many of our subscribers are actually called and what values they get. We don't want to just send everyone, say, a 5 or a 4. We want to give them different values depending on what our actual goal is. So yeah, this clock is not like an end class, it's a working point that will work currently, and then we can possibly expand upon later because we're still in like the rough outlining set. We're not necessarily certain that we can stop and do that, or that we can stop with just this class. So, and the current index, very straightforward. We're just holding where we are in the list presently. So, iSubscriber notification, sub message. So this is our subscriber notification that we need to pass into notify methods in order to properly communicate with different subscribers. And then we have the end region vars. So this ends our variables and we enter our methods area. Quick water shot. So as we move into the methods, or into the madness, we have virtual void setup. So we have a sub message equal to a new clock notification. So this is done because we can't really construct a struct based on our time interval in the beginning of the class. So if we did that here in our variable section, this would actually cause an error because time interval doesn't exist until after the instantiation of this object. So we need inside a method to do that. I'm gonna do a quick Control F for on enable. And I notice how it's not here. So setup needs to run on enable probably. So let's do a protected virtual void on enable parentheses enter brackets enter. And we're just going to run setup. And this is just going to tell it that when we set up, we're going to, once we set up, we're going to be fine. And we're just going to get the sub message and construct a clock notification so that our clock can update our subscribers. And then we have public virtual void check time step. So our time step is our time interval. And you'll notice it's capitalized. So let's actually go down to the accessors before we continue the time step. So for our accessor, what I've done so far, and this math is subject to change currently, subscriber count. So I want time interval to represent not the interval of time we're expecting. I want it to represent, okay, let's try a different way. Time interval lowercase represents the amount of time I want to update all subscribers in a list. So I want to have capital time interval be an accessor that I can find the actual interval to update a single subscriber. And I want if subscriber.count. So if the count is greater than 0, I actually do what's in here, which is return time interval divided by subscriber count. So this is not actually like this is a mathematical condition where I can't divide by 0. So that's why this if statement isn't here. Otherwise, we could simply have time interval divided by 0, and else we just return 0. So this should be fine, and time interval should never be 0, because if you did that, nobody has a time interval of 0. That would be an infinite loop, and it's already broken. So, which we could add an if statement in here for, maybe we should. And, which is, that's not it. It's kind of hard to, there it is. Despite using it a lot, I never remember that it's under 7. So this would be time interval, because you can't have a negative time interval as well. So as long as it's greater than 0. So as long as these two things are true, we can return this. Okay. So with that making sense, let's look at time step. Well, time step does execution, so let's first look for when it's called. So this time step is called when the clock is run. So you'll notice that in our clock manager, we call run clock on update and pass in the float time. So when we run this clock, we pull in and add to time elapsed the a delta time, and then we check time step. So check time step is meant to be our action here. So what's our action do? We check time interval, and if time interval is greater than 0, while the time elapsed is greater than or equal to the time interval, we current index is greater than equal to subscriber.count. So, okay. So while time elapsed is greater than or equal to time interval, we loop through this. And this loop is meant to make sure that we stay within the bounds of the list. So setting our index to 0 if we exceed it, exceed the available indexes, and decrement the time elapsed. So this is our exit condition, meaning that time elapsed minus time interval eventually leads to exiting this loop. And I'm gonna flip that out with that, just to make sure we're keeping on the same time. So theoretically, this probably still results in all 4 of these running. Well, all 4 of them should still run in the full interval, but if we start, like, say we add 0.5 and we only add on, or we only run a single instance on 1, then every 2 frames will run 1. So it will limit that way. It's a little less, yeah, so it helps distribute our frames a little bit. And this is what here distributes it. So subscribers current index, so that current index we're tracking. And then we're calling to notify the sub message. So on notify, we're calling on the subscriber, and we're passing in sub message, which is our clock message. And then we increment to make sure we move on to the next instance. That's why the if statement is here and not at the end, because then we can cleanly increment every time and also make sure we aren't outside the list before we begin. So moving on to subscribe and unsubscribe. So basically, when a user subscribes to this, we add subscriber to our list. And when we unsubscribe a user, we remove them. We could also, should probably also call, and this is something I added a day or 2 ago, I think. Subscriber dot on unsubscribe. And the reason I did that is just so that it can, there's certain things they do when they unsubscribe that they might want to also call. Where this is a little less like that, because usually the subscriber calls this. So they pass themselves in to subscribe. It's not done by something else, although it could be. That's just kind of the way it is right now. The notify, so we don't quite run the notify in the normal way because our check time step does that. So run clock to check time step runs all this logic. We don't necessarily need to use the notify, but we do need to implement it because we implement iSubscription. And then we hit the accessors, so we've made a full loop through the code. So what does this look like for an item? What it looks like for an item is, I need a trail item. Trail item right here. So what does this look like for a trail item? It looks like a subscription to a clock. So we have protected clock SEO clock. And in that, we have in our... Ignore that. Doesn't look like we implemented that. So we'll go ahead and protected override. Let's go ahead and change this. So subscribing factory item. Right. So instead of doing this directly into the item, I actually did this into a subscribing item. We can do more on that after this section, but basically this guy handles the subscribing factory items. So any factory item that needs to subscribe to something can use this inherited class. And using this inherited class lets us do something like have specific item methods that can be overridden. So instead of implementing the class every time, which would cause us to run into hiding problems, the idea is that the base class is implementing it, and the way the base class is built puts into that implementation things that we can directly override. So creating that kind of flexibility and structure of the structure of an object, but the flexibility of an interface a little bit. And this is just because I anticipate a lot of items needing to subscribe soon, for reasons I'm not quite ready to describe. But essentially, I'm implementing iSubscriber. You can check out one of the earlier videos for that. But it's in the observer videos. So we have factory item. Not much you need to know about factory item. So we have a protected list of iSubscription. So normally I don't keep a list of subscriptions. But in this case, I did want a list of subscriptions because subscribing factory items might subscribe to multiple things. And while the subscription handles notifying the subscriber, it might just be useful if it ever needs to unsubscribe. So this is like a just in case. So then we have on notify. So implement subscriber section is just implementing that. And inside every implementation, I have an item notify, a sub message, or item unsubscribe, which just calls these protected virtual methods out here. A subscription.subscribe this. So if I am asked to subscribe to something, I pass in this to the subscription. So I pass in myself to the subscription, and I add the subscription to my list. The other reason is, now that I'm an object, I might want to unsubscribe. So if I need to, factory items can get destroyed and can get, they're objects, so they get cleaned up on collection. So this is a quick way to like allow me to unsubscribe from things. So for each subscription, when I want to remove everything, I unsubscribe this and I subscribe remove subscription. Which actually means that, what was it? The item trail, why is it not, oh, because I scrolled through. Clock SEO. Maybe this is not a good idea, because I'm already kind of using that for something else. So maybe just removing it is fine, because as long as I remove it from here, I'm not looking for it. Or I'm not getting notified. Whereas this unsubscribe is just to remove it from all of them. So it looks at all the objects that it ever did subscribe to, asks to unsubscribe, and then cans itself. And that's how a subscribing factory item kind of works logically. Thank you for joining us at Bug Free Productions. Remember to subscribe on YouTube at Bug Free Productions and follow on Twitch at JibAtBFP. Have a bug-free day.